Hello and welcome to some more maths with Mr. Thompson, and today we're going to look a little bit more about some of the values you might have to find when you're doing some differentiation, okay, just some very basic things. I think what we're looking at today is making sure we understand the difference between f of x and f dash of x. I'm also going to throw in this f double dash of x, because basically just because you've differentiated the function once doesn't mean you can't differentiate it a second time. It can be quite useful if there's something there to do it with. So I'll just mention the fact that you can do it. I'll do an example, but I won't get into an awful lot of detail about how that second derivative is actually used, but we'll get into it anyway. Okay, suppose we've got a function 5x cubed plus 3x. If we differentiate that, we get 15x squared plus 3 to get f dash of x. And if I want to, I can differentiate that again and get 30x. So basically, I'm differentiating that one to get that one, and differentiating that one to get that one. Okay? But maybe I'm asked, what is the value of f dash of x when x equals 2. So when x equals 2, the actual function f of x is 5 times 2 cubed plus that, which is 5 is 40, plus 6 is 46. Just check that, 5 is 48. But f dash of x is actually 15 times 2 squared plus 3, which is 463. Okay, so the value of the function is 46, its gradient is 63. That's the difference between finding the actual value of the function and the value of the gradient. So here's a couple of questions you might get asked. You might say, you might be asked, find the point where f of x equals 6 plus 14x minus 2x cubed has gradient equal to negative 10. I'm going to say points there because there may be more than one point. Okay, I want to find the value of x. So this gradient has the curve has a gradient of negative 10. Now, first of all, notice this is a double bend curve. As x gets very big, it's going to get large and negative. So there's going to be, I reckon, 2 places where that curve has a gradient of negative 10. Let's see how we go on. We're looking for the gradient negative 10. That means I have to find f dash of x to get the gradient function. And I get the gradient function, I get 14 minus 6x squared. And I want to find x when that equals negative 10. Let's do some rearranging. I get 24 minus 6x squared equals 0. So that's 6x squared equals 24. So x squared equals 4. Now, I said there was 2 places that the gradient can be negative 10. And that works because, think about it, 4 has 2 square roots, either positive 2 or minus 2. So basically, I'll get that happening at negative 2 and I'll get that happening at positive 2. Okay? 2 points, 2 places to find where that curve has a gradient of negative 10. But we're asked to find the points. All we've got so far is the x values. We know the x values are 2 and negative 2, but we have to find the y values that go with them. And we get them by replacing these two numbers back in to the original function. I have to find f of 2, and I have to find f of negative 2. So f of 2 is 6 plus 28. That's 8 minus 16, which is 18. So the point there is 2, 18 is 1 point. Down here I get 6 minus 28 plus 16. So that gives me the point negative 6. So the point there is negative 2, negative 6. So there are two places where that function has a gradient of negative 10, 2, 18, and negative 2, negative 6. I'm going to do one more, and it's going to lead into something a bit more detailed later on, but we'll just start with a simple one now. Find where y equals x cubed minus 3x squared minus 72x minus 10 has turning points. We know it's a double bend curve. It's a positive x cubed, so it's doing something like that. So in two places it's going to turn around. We have to find out where those two places are, and what we know is that at that point the gradient equals 0, and at that point the gradient equals 0. So what do? We find y dash, we put it equal to 0, see what we get. Y dash is 3x squared minus 6x minus 72, and that equals 0 at max or min. Okay, well, let's make this a bit easier. So that's 3x squared minus 2x minus 24. And look what we have here. We have to factorise a quadratic. Remember, we've been factorising quadratics for a couple of years now. Sometimes wondered what they were used for. Here's what they're used for. Let's factorise it. I get x minus 6 and x plus 4. So when we factorise that, we get x minus 6 and x plus 4. And that means that x equals 6 and x equals negative 4 at the turning points. What y values go with these? Well, I replace what x equals 6 and negative 4 back in to the original function. And when I do that, y of 6 is equal to negative 334. Y of negative 4 equals 166. So the turning points are 6, negative 334, and negative 4, 166.